And we're live. Hello, hello. As per normal, gotta find myself. So I am going to look for myself right now. And I'll say hello when I can see you or hear from you. Hey, it did it fast this time. Cool. I beat anybody's comments. Hey yo, Margaret. Okay, I gotta resize this. I was worried it might not show fully. There we go. Hey Drew, welcome. Hello Elizabeth, Caitlin, Chelsea, Andrew. We had a staff meeting at 9 a.m. this morning, so I actually had to wake up early. So I'm rolling with like 5 hours of sleep. Feels bad. Nothing should be at 9 in the morning these days. Can't believe I normally get up at like 6:30. Oh gosh. That is not a time humans should be awake. Anyways, this is a question you should be working on. You shouldn't need a calculator for this, but I don't think it would hurt you. This is a no calculator question, but it's also not one you'd use one for. So it has that going for it. So I'd like you to try this question out. Hello, hello, welcome Aspen. Also, I'm getting some. I've gotten a teacher complaint of people asking to like switch to other live classes to attend this. Remember, you can watch this later. I just don't say hello to you. So please don't tell other teachers you have to be here at 1 p.m. because then I get yelled at for breaking the rules when I have asked that you not do that. So yeah, causing drama. So attend if you can, and if you can't, it's okay. You can watch it later. We aren't going to have an attendance doc for today's live stream. We're actually having an AP classroom assignment. They uploaded some new free response questions, so picked out a few of those. And with any luck, they're not too hard. I probably should have looked through them a little more. Oopsie daisy. Dun, dun, dun. And hello to our new additions of people: Victor, Sanjana, Sam, Vinny. Welcome, welcome, welcome. There's a question here for you to be taking a peek at. Hello, Tim. Welcome. Good afternoon, Rose. Welcome. And Bryn, hello. So yeah, this is a free response question I would like you working on if you just showed up. What? Oh. Okay. Good day, Nick. Stop breathing into the mic. Well, the mic's really close to my face, and I don't feel like upgrading a mic. So when I laugh, you're going to hear my breathing into the mic voice. Also, it's allergy season, so rip breathing. Ugh. 'Tis the season. Hello, Daikun, welcome. Keith, welcome. Hello. Hello, Maddie. This question here is very much shades of chapter 3. The derivative applications chapter. This is definitely one of those kind of questions. Hey Max, hey Michael, welcome, welcome. Cool. I think all of these questions off this assignment are doable, and hopefully are not ones I've assigned before. I don't think I recognize them. Can you grade the FRQ optional practice online for me, since it says the AP Classroom does not automatically grade FRQs? Yeah. I went over all of the questions for a lot of the early ones. I will be definitely grading all these ones in this period where these go in the grade book. Like the assignment I put in the grade book for today is definitely going in the grade book, so I definitely have to grade it. However, it will be graded for attendance, but you can't just write like A, I don't know, B, I don't know, C, I don't know, and that sort of thing, because that is not attendance. So maybe putting I don't know for one of them is reasonable if you actually don't know, but you have to try your best on those to receive attendance credit. What assignment? The assignment I put on AP Classroom earlier today. That is the assignment that I am assigning today. And so that is why we do not have an attendance document for today's thing. And yes, there is AP Classroom required work now. Yes. We had a bunch of AP Classroom stuff during the non-required period of school because that's how things worked, which is also wrong. Whatever. Anyways, and now this is gonna be part of the assigned work for this after the fact thing. If you caught my email earlier today, you know that I am thinking about ways to affect grading, but I cannot offer quiz retakes because there's no way to ensure that they are fair or anything like that. Is that due before next stream? Yes. Yes, it is. That's when I'll be putting it in the gradebook, at least, is before next stream. As per normal, I'll wait for like 8 dones and then start rocking it. So I'll give people more time. We don't just go when the sophomores want to go. How do you feel about the grading system, though? Not good. We had a staff meeting today, and I tried to ask the question, but it was not answered. Like why do we have grades and why does Bellevue and Seattle have A's? I don't know. I'm I'm sad about that. Not every other district is pass failing, but a lot of other districts are doing A or incomplete because we're not allowed to pass fail. Um, but regardless of what your grades are for this semester, they might not even be factored into your GPA because they'll always have an asterisk next to them. So I'm not sure your grades this semester will matter in the long run, besides giving you high school graduation credit at all, uh, even though it's not pass fail. And yeah, that was essentially my take, Vinny. Yeah. I should be tactful about this because I shouldn't make anybody mad, but I was not happy when that came out. So, yeah. And, Ethan, this is a free response question. Oh, yeah, yeah. Sorry. If you didn't see my email that I put out today, uh, the most likely thing that I am thinking about, because I've been brainstorming a lot how to make grades work or whatever, is if you do everything starting April 20th, I'm just going to average 100% with your grade in the class. So, grade inflation, yay. Not okay language. Curious. Liam always with the helpful comments. uh, by the way, if you don't understand how the math for that works, if you had a D, you could get a B just by doing everything. If you had a C, you could get a B plus just by doing everything, or even an A minus. Kind of depends on your C. No, it's just a B plus, B or B plus. So I'm thinking about doing something fairly drastic because I just want people to be involved. I want you to do the best you can on the AP test. That's all I really care about. Mostly because I want you to do the best you can so you can be the most prepared for the future. I just want you to be smart. That's the whole reason I got into teaching. I wanted to help people be more smart. That's it. That's all I care. I do not care as much about grading as some other folks. Yes, if you do everything, that was my plan, Chelsea. That's not in stone yet, but that is my current line, my current best option. I haven't fully decided. uh, what's the name of the assignment we were supposed to do? What is it called? I have it open in a tab here. Dang it, what is the tab where I have it open? And yeah, I'll go over this in just a minute or so. Since a lot of done's piled in, I just want to answer Liam's question on what is it called, because I don't remember. It is called 427 FRQ Practice. That's a good name. So the first assignment, Sam, I actually counted. Did you attend the live stream as an assignment? Those were worth 5, whereas I'm probably going to give more points for these or whatever. But yeah, you should average with the 100% and then add 0.5 of a percent. That's kind of funny. Are there going to be hard deadlines? Yes. June 20th is a hard deadline. So yeah. Uh, that's what's up. All right. Mr. Kennedy, I don't have that assignment. You should. I assigned it to all 3 classes. I definitely have that in here. Let's find your name on the list. Yes, I have it assigned to you. I just checked, Liam. That would give me a name. Yeah. Okay, so I'm going to get started in going over this. We'll see how people did and that sort of thing. Okay, so it says first thing, find the slope of the line tangent to the graph at x equals pi. Here. Now we're looking at the graph of f, and f is this thing. So it has nothing to do with the h. So all we're going to do is take the derivative of this. And then plug in pi. So you get -2, sine of 2 pi is 0. Okay. Plus e to the 0 for sine of pi times cosine of pi, which is -1. So it's -1. Chillin'. Sorry, breathing into the mic because I'm laughing at you, Liam. Anyways, B. If you're trying to find k prime, you got to take the derivative of h, which is h prime, and then you got a chain rule. We are trying to find the value at pi, so I got to find f of pi. F of pi is cosine of 2 pi, which is 1, plus e to the 0, which is 1. So 1 plus 1 is 2. So this is h prime of 2 times f prime of pi. I already found that. That was part 1. That's -1. So I don't even need to write f prime or anything. That's -1. So all I have to do is figure out what h prime of 2 is, which is the slope at 2, which is the slope of this little derpy line, which is -1/3. And so it's -1/3 times -1, which is 1/3. Chillin'. Next one says, let m be defined such that m is g of -2x. Times h of x. Find m prime of 2. So I'm going to wipe out my work here thus far. We're trying to find m prime, so we're going to take the derivative of the right side here. We got to do a little bit of product rule. G prime of -2x times -2 times h of x plus g of -2x times h prime of x. That's our product ruled out m prime. We plug in 2, so we get g prime of -4 times -2 times h of 2 plus g of -4 times h prime of 2. All right. So now we have a bit of a mess of things. G is the table. So g prime of -4 is right here. The slope of that graph is 1/2. H is my previous question. Or actually, which one's H? Oh man, there are so many variables in this problem. Oh, H is this graph. Oh, beautiful. Oh, G's the table. Oh, sad panda. I goofed on the first part. G of -4, I can just read from the table. Oh man, this is brutal. Whoops. Yeah, that's actually what I wanted, was that one. It's 5. G of -4 is 5. Oopsies. H is the actual slope of the curve, which is -1/3 at this point. Oopsie daisy, oopsie daisy. G! Oh, I wanted G prime of -4. Oh man, I am goofing hard. Okay, G prime is -1 at -4. G is 5. I can read good. Eventually I'll get there. And did I goof up H also? Yeah, okay. So, to summarize all of the horrible things I just did, the actual value of the curve here is -2/3. That's what I use for H of 2. The slope of that line is -1/3, and that's what I use for H prime of 2. So I goofed quite a few things here. But I believe it is all fixed. So G prime is -1 at -4 Negative 2 is negative 2. So yeah, this part's all good, and we get 4/3. Plus negative 5/3, which is negative 1/3. Q. Because they have the same bottom. That's very nice. Lastly, is there a number c on the closed interval negative 5 to negative 3 such that g prime of c equals negative 4? So we're going to g, so we're looking at the table here. So from negative 5 to negative 3, that's this interval. G prime goes from negative 3 to negative 1, and then from negative 1 to 4. This is not looking like there's a spot where the slope is negative 4. But to verify that, we need to use the mean value theorem, which is where I find the average rate of change across this interval, which means I do 2 minus 10, y2 minus y1, for this bigger value in the interval and the lesser value, all over negative 3 minus a negative 5, and I get negative 8 over 2, which is negative 4, which means, heck yes, the mean value theorem says negative 4 must be a slope on negative 5 to negative 3. And it's because the average rate of change is 4. And so that was actually a hard one. Because it doesn't look like it at all. Because the slope goes from negative 3 to negative 1 to 4. It doesn't look like it's going to go to negative 4, but it's pretty obvious when you do y2 minus y1 over x2 minus x1 that it actually has to go through negative 4. We just didn't get a value in the part where it dips way down. So, yeah, that was a pretty tricky question with a lot of different parts there. And sorry I got so turned around with the F's and G's and H's and M's and K's. Oh my gosh, there are 5 different letters in this question. Oh man. Okay, so a few things about that, Andrew. First, what I should have done is I should have said G is differentiable, because it's really important that G is differentiable for this to be true. So the 3 things you need are G is differentiable, you need to mention the mean value theorem, and you need to say the average rate of change on the interval is 4. If you have those 3 parts, you have everything you need to get all of the points on the question. So again, it's average rate of change equals instantaneous rate of change. That's mean value theorem. You need to say the average rate of change is, negative 4, not 4. And lastly, you need to mention that it's differentiable. I still got it wrong. Oh, that one? It's negative 4/3? Oh, poopy fart nuggets. Let me take a peek Saruni and laugh at myself for my faults. Did I just multiply wrong? Yeah. No, I definitely multiplied wrong. This was negative 4/3 plus negative 5/3, which is negative 9/3, which is negative 3. Wowzer. C was a disaster. Oh man, I can't believe I multiplied wrong. You can tell I got 5 hours of sleep because of that staff meeting, because I'm making mistakes left and right. Feels bad. So yeah, this one was negative 4/3 plus negative 5/3. Sad, sad, sad. But D, I really wanted to put a mean value theorem question on here just to make you think about that, because it looks like, I bet on the actual AP test that the kids took this, 80% of kids said, nah, it ain't happening, and it was. Alright. Sorry about the scrub life I was living there. Here, okay, we have a pond. this was a question. One of the questions on the homework was a repeat, so I'm not going to go over that one. But I was going to go over some of the other ones on the problems that I gave. Use data from the table to find an approximation of W prime of 12. There are a few different plays here. The best play, in my opinion, is to do W of 15 minus W of 9 over 15 minus 9, like that. If you do this, you get, what is it? W of 15 is 21 minus 24 over 6, which is negative 3 over 6, which is negative 1/2. But the AP test actually gave you credit if you did W of 12 minus W of 9, or W of 15 minus W of 12. So I think it's better to go across the 12, but they gave you credit if you use 9 and 12 or 12 and 15 as your endpoints. And that's all you really needed to do. You had to put units, degrees Celsius per day, but they were a little forgiving on that. Is this question 2 from the homework? Yeah. Question 1 I actually went over during last live stream, I think, which was, oops. I accidentally copied it twice, which was a mistake. Oopsies. Approximate the average temperature in degrees Celsius of the water over the time 0 to 15 by using a trapezoidal approximation with intervals of 3 days. So yeah, 3 days, is pretty obvious because that's what we're given. The reason why we need to use trapezoids for this is we integrate and divide by the width to find the average. So the width is 15, and instead of integrating, I'm going to be using 1, 2, 3, 4, 5 trapezoids. So all I do for trapezoids is I find the number that's halfway in between these and use that as the height of my rectangle. And I just go through and do this for all of these. And I treat it like rectangles. Cool. Now that I've averaged all the y values that are adjacent to each other, I just do 3 times all that crap added together. So 25.5 plus 29.5 plus 26 plus 23 plus 21.5. And that would be the approximate temperature. If you math this all out, you get 25.1 degrees Celsius. But you can actually leave it like this and just say degrees Celsius. Although on the AP tests, this time you're going to be given a calculator for everything, so you might as well just plug it into a calculator. Save yourself hassle. All right, C says a student proposes a model for this temperature, so an actual equation that these data points somewhat go through. Find P prime of 12. Okay. So all we do is we would take the derivative of this, or if you have a calculator, which you do, you can just take the derivative at a point. So take the derivative of 20 plus 10t e to the t over 3 at t equals 12. So again, you have a calculator for this, so you don't even need to know how to take the derivative of this. You can just say the derivative, plug in the points. And if you don't remember how to do this, if you have a graphing calculator, menu, calculus, and then derivative at a point, numerical derivative at a point. And on the actual AP tests, I would, if you don't have a graphing calculator, like get Desmos on your phone or something and use that. That would be my recommendation. All right, the last one says, use the function p in part C to find average value in degrees Celsius of p of t over the interval 0 to 15. So for this, we're also going to use our calculator and integrate to from 0 to 15 and divide by 15. I guess I didn't talk about the, explain the meaning. So we found that value, which was negative 0.549. I didn't actually say it. It's in degrees Celsius per day, and it's the change in degrees Celsius per day. So the speed in degrees the temperature in degrees Celsius is dropping by 0.4549 degrees Celsius per day. That's what you would say. All right, last part says average value. I started with this integral from 0 to 15, and all we do is dump in our function. So it's literally just p of t dt, and you dump this into a calculator, and you get an answer, which in this case was 25.757 degrees Celsius was the average temperature, which is pretty warm. I have not heard anything about that, Daikun. I only heard about that hearsay from students, I guess from you. So I have not been asked, and I would not do it. So, hey. Our last question says there's a cubic polynomial here. It has a minimum at -1, and it has a point of inflection at -2. And the first one says find the actual total function, so find a and b. And so this is going to require actually a fair amount of work. We're going to have to take a derivative, 12x squared plus 2ax plus b. That's f prime. And the thing I know about this is that it has a minimum at -1, so I know this thing will give me -1 as a root, but that's not where I'm going to start. I'm going to go further into this. I'm going to take another derivative. And if I do this, it says I have a point of inflection at -2. So if I have a point of inflection at -2, all I have to do is figure out this equation. Wait, why did I put an equals there? Oopsie daisy. And so you get -48 equals 2a, or positive 48 rather, when you add 48 to both sides. And you divide by 2, and you get 24 equals a. And nicely enough, that we're done with part of it. So I can dump back into the derivative step. Whoops, not 2ax. It's 12x squared plus 24 times 2 is 48. I can write the right thing. 48x plus b. And I just need to find b such that -1 is a local minimum. So, what should I do here? I should take out a 12, like this. And then if I have a 4x here and 1 is one of my minimums, I probably want something like x plus 3 and x plus 1. Those add to 4x, and there's a -1 that is one of my possible answers. And it's a cubic function, so its maximum would happen first, and its minimum would happen second because it's a positive cubic function, so this checks out. So all I want is for this last number to be 3, so I want b over 12 to equal 3, so b is 36. B down. And so that was a lot of heavy hitting there, just kind of back to back to back, but we have found the full equation now. So this was a 5-pointer. This was a lot of stuff. Now the next part is a 4-pointer, and this one was only a and b. So let's see what we got. If the integral from 0 to 1 of f of x dx is 32, what is the value of k? Oh, geez. So I probably should keep my a and b values. A is 24, b is 36. Q. Erase, 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 erase. Okay. So the integral from 0 to 1 of f of x dx is 32. We're integrating, whoops, I'm not ready for that. From 0 to 1 of 4x cubed plus 24x squared plus 36x plus k dx. Okay, don't need you anymore. And so we integrate 0 to 1. 4x cubed integrates to x to the fourth plus 8x cubed plus 18x squared plus kx. We plug in 1 and 0. We get 1 plus 8 plus 18 plus k minus 0. And I want this to be equal to 32. So what value does k need to be? Well, this is 27 plus k equals 32. That's pretty easy to solve. So k is 5. Easy money. So the answers were all whole numbers on this one. But there was a lot of janky math to get to those whole numbers. Ooh, missed some questions. Sorry. Can you substitute negative 1 into f prime of x and set the equation equal to 0? Absolutely. You can absolutely do that. That would totally work. Totally. I am doing the completing the square way because we're teaching completing the square in Algebra 1 like right now. So that was what my mind went to right away. But yeah, there are quite a few different ways to do that kind of question. Yeah, Chelsea, you're totally legit. Same with Rose, Michael, Aspen, Drew. Yeah, like that's all legit. So if you don't understand what they are talking about, what they're saying is at the derivative step here, 2ax. Why did I write b? So we had figured out b was 36, I believe. No, yeah. Or a was, yeah, b was 36. Cool. Or a was 24. That's what we knew. So what you can do here, if you don't want to do all that work I did, is just plug in negative 1. And you get 12 plus 48 times negative 1 plus b equals 0. And you can solve this for b. And this is probably a lot easier than what I did, the factoring way. Because you can just combine these, negative 36 plus b equals 0, so b is 36. That's totally legit and works fine. Probably is easier to understand, too. I just like factoring. All right, I got 3 more questions for you, so a little break from me talking. These are kind of a variety style of questions. With any luck, they're all solvable. Yeah, they are. And I'll be back in a jiffy. I'm going to go get some water. So you can listen to the quiet sounds of nothing for a minute here. Haha. All right, back with water. After this, I'm going to be asking for some input from y'all about mock testing kind of stuff. Although getting a mock test for this test is really hard because this test didn't exist a month ago. This year's AP test. Should we just use the link you posted on earlier live streams for the check? There's no check-in for attendance today because what I'm assessing for this class is actually the homework because it's on AP Classroom. So I'm trying to mix up what I assess, because I'm allowed to assess 45 minutes a week, but realistically the AP test is 2 weeks from today, basically. So we need to be doing a lot more than an hour and a half of work a week if we want to do well on this. So I'm swapping around with what I'm assessing. Homework will be due Thursday, correct? First duns are sneaking in. We'll wait a little longer for more. Oh, whoops. I meant to make the second question something different. I made it a little easier. Oh, well. How many duns is that? That is 8. So I will wait for one more, and there it is. That is 9 duns. Let's mob some calculus. So for the first one, if you made U the bottom, du was almost the top. Almost. Except negative. And without the 3. So if we divide by -3 on both sides, we actually get rid of this and get rid of this, and it's perfect. Which means we have -1/3 of the integral of just du over u. Which means this integrates to natural log of the absolute value of cosine of x cubed plus c. And it's that kind of nonsense. The second one, I meant to give you this question for the record, where the squared is there, but I goofed when I wrote it. So it's easier. It's another u substitution. If u is x squared... Wait, no, this is a derivative. What am I doing? It's product rule. Take the derivative of the first thing, which is 1 times cosine of x squared, the second thing, plus the first times the derivative of the second, which requires us to do this, and then chain rule out a 2x. And so it's just this. No need to simplify further. And lastly, we're taking the derivative. Natural log stuff, all you do is u prime over u. And the derivative of x is 1. Please, 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 don't think you can simplify this. Part of the reason I put this question here is I really wanted people to not simplify this. So I wanted to remind people that while you can simplify natural log of e to the x, no problemo, that's x, you absolutely cannot simplify natural log of e to the x plus 1. The second you put the plus 1 in there, you're stuck. It's as is. So that's part of why that question was there. Alright, yeah, I got 2 more. Questions based on questions I had last time. As I skip around in my little presentation here. So, first one is a differential equations question. Second one's a related rates question. Lots of words. The first one's a bit of Newton's law of cooling, which I wrote there, so you don't have to make it up. Oh, did I goof it? Yeah, I goofed it. I forgot this. This is a wrong equation. Let's fix it. Ha ha ha. It's this. There we go. My B. Now, just a couple extra hints. 20 degrees Celsius is like the T O or T, whatever this is, the T of the room. I could call it like TR. Maybe that's a better moniker. And T is the T of the drink. So those are the two different big T's. The little t on the bottom is time in minutes. So those are some pieces you might need to solve this. Again, our differential equation I rewrote as dt over dt equals k times big T minus T of the room. And I did tell you the room is 20 degrees Celsius, so you can make that equation even better as is. Even before doing any calculus. I think we'll do these one at a time. You're welcome to work on both of them or whatever in whatever order, but please tell me when you're done with the first one so we can talk about that. Somebody was asking about doing a KEKT problem last stream, and I didn't do it, and so this is that question that I doing to acquiesce that concern. The first question is a bit meaty, so that's why I'm okay making it its own time period. Should have just put these on two different slides. Oh well. I believe we did one of these types in class, the Newton's law of cooling ones. I think I did it as an example, so this is the first time I've asked it of you solo. So, yeah, just let me know when you are finished with that first one. Or at least have given up or have gotten as far as you can. Remember, you should try to use an integral on it. There is definitely some KEKT in there. But it's like KEKT with a little extra this time around. I'll start sneaking in some hints. think the second question's actually easier than this. These are a little heavier, but I have finished all the calculus parts of this question already on the screen here. So folks, I'm going to start talking through this a little bit. To separate variables, you move the dt over to the other side, and you divide by the parentheses t minus tr. But tr is 20, so I just plugged it in to the room. It's 20. Then we integrate, and we just get natural log of the bottom on the left side. And on the right side, we get kt plus c. Then we e both sides, which is how we get rid of the natural log on the left, and get kect on the right. I add the 20 to the other side, and then the t is initially 50 degrees Celsius. That means at time 0, the temperature of the t is 50, which means, whoops, c is just 50 minus 20, or 30. And so we can actually build the equation t equals 20 plus 30 e to the kt. And then we can use, why are you using the 20? Because in my equation here, in my differential equation, the rate the temperature is changing is always proportional to the difference between the temperature of the tea and the temperature of the room. Like if I take a 100-degree coffee and put it in a negative 20-degree freezer, it's going to cool down real fast because that temperature difference is 120. And if I bring it into a 90-degree room, it's not going to cool down very fast because it's the difference between the temperatures is pretty close. How did I separate variables? I just divided by the parentheses t minus tr here on both sides, and I multiplied by dt to get the d little t to the other side. And that's it. So just multiplication and division for separating variables. Now we plug in our other condition, 40 degrees after 10 minutes. So 40 equals 20 plus 30 e to the k10. We solve for k here. Subtract 20, or we get 20 equals 30 e to the 10k. So 2/3 equals e to the 10k. We natural log. So natural log of 2/3 equals 10k. I realize I blazed through a lot of these steps. I probably should slow down a little bit. I divided 20 by 30. That's how I got 2/3. I natural log to get rid of the e. And that's how I got this. And then I divide by 10. And I get k equals the natural log of 2/3 over 10. And all we have to do to finish the question is plug this k in to our equation up here, this guy, and plug in 30. So we get t equals 20 plus 30. E to the k is natural log of 2/3 over 10. And I want it after 30 minutes. So the answer is 20 plus 30 times, if I put the 3 in here, the 30 divided by 10, which is 3, then I can just say times 2/3 to the third power. And so that's the temperature of the drink. It is 8/27 times 30 plus 20. Hello and welcome, Jonah. We just did a related, or differential equations question. Which is this guy right here. Second one is related rates. Go ahead and try that guy out. I'm going to go over it in just like 3 minutes or so. That one should be easier than the one I just did. For that final step, did you do E of natural? Yeah, that's how I canceled them out. If I put all the numbers in the power, which is what I did, I'm allowed to cancel out the E and natural log, and I just get 2/3 to the third power. Which, again, you'll get a calculator on this test, so you can do this on a calculator. I just didn't feel like using the Desmos that is clearly in front of the screen in front of me. So, yeah. What is this? Here, I can, if you use the calculator, I can actually not be lazy for a second here and see. I got 28 and 8 ninths, 28.888888 degrees Celsius. So a little bit cooler than 30 degrees. You can see it cooled 10 degrees in the first 10 minutes, and it cooled only like 11 degrees in the next 20 minutes. So its speed of cooling was shrinking as it went along, which is consistent with intuition and physics, which is good. Physics are good. Huh. Waiting for my stream counter to move to 56 minutes, and then we'll see how people did with the ladder. As per normal, one of the benefits of live stream is if you're struggling with this question or you need more time, you can just pause and then restart it. That's the benefit of making these a video, and why I like that. I can't blaze past you on this. All right, hopefully you drew a picture like this for this question. Whoops, the ladder's 13 feet long, not 13 feet high. You can find this third side because this is a right triangle. So 169 minus 64, c squared minus a squared, is 105. So this side is root 105. And if we know that, we know almost everything we need to know. We know this side is shrinking at 2 feet per second. So I know this is negative 2 feet per second, that rate. And so all we do is a squared plus b squared equals 13 squared. Oh, okay, Kennedy, I'm pausing so you can finish. Okay, that's fine. No worries. If we take the derivative, we get 2a dA dt plus 2b dB dt equals 0. I need to define what the sides are. It didn't matter which one you chose. I'll call this A and call this B since I'm trying to figure out how far it's moving up the wall. So I want dB dt based on how I defined it. You can call it whatever you want. You could swap the A and B in, it doesn't matter. But the point is, I can plug in 8 and negative 2. I can plug in the root 105. And now you just mob this question. So the 2's cancel, so I can just get rid of those. I can divide by 2 on both sides, is what I'm trying to say. We add this over to the other side, and we get 16 equals root 105 dB dt. And we just divide by root 105. And we get our answer, which is that it's sliding up the wall at roughly 1.6 feet per second, so a little bit slower. So yeah, sorry for losing those of you. Maybe I didn't wait long enough on that one. But this is a little old school related rates just with triangles. No angles on this one, none of the super janky stuff, just Pythagorean theorem. Some key details along the way. I was able to plug in the 13 from the get-go because the ladder is always 13 feet long. This is not an adjustable length ladder according to the question. I was able to plug in all the sides after the derivative, but I couldn't plug in the other two sides before the derivative because they're both changing. How far the ladder is from the wall is changing because you're pushing it in. How far it is up the wall is changing because it's sliding up the wall. So there's some nuance there where you have to remember to plug in the stuff that's changing only after you've taken the derivative, and the stuff that isn't changing you can plug in before the derivative. And so a little bit of related rates. Alright, Daikун's off to AP Lang. This is great timing. If you haven't seen this, what I posted on the last calendar thing, this When You See AP thing, this is a really helpful presentation to go through. If you have not looked through it, it could help you with some key vocab. Otherwise, the homework's on AP Classroom. There's no attendance document this time. And I'm going to wrap up here. Unless there are any questions, you can get off to whatever classes you have, or get off to do this homework, or whatever you want to do. But I'll hang out for a minute and just see if there's anything. Oh, you caught up. Nice work, Aspen. But you're welcome to go. Do you know when you're going to do the mock exam? Oh, crud muffins. Yeah, hey, those of you who are left. It needs to be outside of the school day. Would you rather have it on the weekend? Or I was thinking alternatively, like one of the weeknights this week. So which is better for people? Weekend or weeknight? And by night I mean like at 4 p.m. or something like that. It's only going to be 45 minutes long. It's not going to be 3 hours. But I am curious if you could just tell me weeknight or weekend, which one is better for you to attend these things. Hmm. 4 p.m. is way past my bedtime. That's about when my brother wakes up most days. Anytime I'm not doing anything else. It feels like weeknight is where we're leaning. So then, which... 8 a.m. Sunday. No. No. Where would I hold the mock test? It would be online. You could do a straw poll in your next email. Not enough people like respond to those. Weekend, please. What I'm thinking is we do one of each. So I'm thinking I'm going to do one weekend and one weeknight. Because I want to offer two opportunities. If you read this week's email, you know I'm giving a 5 out of 5 quiz. So this is more grade inflation that isn't tied to the averaging of grades thing. If you attend one of these two sessions. On a weekend, it would probably be at like 1 p.m. On a weeknight, we're talking like 4 p.m. So these are the rough times. So, yeah, okay, what I'm thinking is... I'm debating. My schedule end of the week schedule is pretty busy this week because I'm turning 33 this week. So do we have to do both of these on time? No, you only have to make it to one of these two. If you make it to both, fantastic. If you can't, that's also okay. I'll send out the dates in an email on Skyward. Do we have to do this on time? Yes, you do, because these are unreleased documents. And they're going to be like 45-minute segments of unreleased. So... So yeah, I got to figure out when people are coming over / when I'm having Skype meetings with people and stuff based on this week. When is the quiz? There is no quiz. But when this mock exam will be, I'll probably do a weekend this week because that's better for me. So I gotta talk to my wife because we're visiting her parents, or her parents are visiting us. I'm not sure, but someday on Saturday I'll figure it out. Uh, so I'm thinking Saturday this week, and then next week I'll do one on a day, Saturday. Um, and maybe what day is probably good? Oh, you know what we could do? We could just do it during the Wednesday live stream. We could maybe do it during that time because that would be efficient. So these are my first initial thoughts. We'll do a couple mock exams. These will be different, so if you show up to both, you will be taking different things. Um, yeah, I'm going to be doing a lot of grading on AP Classroom in the next 2 weeks. Just realized. What time on Saturday? On a Saturday, I don't know yet. Crap. I was gonna make a time, and then I realized I actually have to plan around my wife's parents, and I don't know when they're hanging out. So I will send out an email later today with that information on AP Classroom, or not on AP Classroom, on Skyward. So sorry I can't give you more right now, but it sounds like that. But the times are okay for some people. I'm thinking Wednesday 2 p.m. Next week we do this for 45 of the minutes, and then Saturday, I don't know yet. Maybe 1 p.m., maybe 4 p.m. Kind of depends. So that's my plan. So again, all of these are like 5 to 8 days from now. So that's when we'll be doing mock exams, and I will be grading. So yeah, sorry for keeping you late here, and thank you for attending and giving me feedback. I really appreciate it, because it's nice. Hasta luego.